Module 7, problem number 10. The data in the accompanying table represent the population of a certain country every 10 years for the years 1900 to 2000. An ecologist is interested in finding an equation that describes the population of the country over time. Complete parts A through F below. We have our data set right here. Let's look at part A. Determine the least squares regression equation treating year as the explanatory variable. Choose the correct answer below. So let's go ahead and open up our data set and then click on the icon to open it in StatCrunch. Pull it over here. All right, so now we have our X and Y variables. We're going to go to Stat, Regression, Simple Linear. We're going to select our X and we're going to select our Y. You'll see in a little bit that as you get more familiar with these problems, you'll see other settings you can adjust so that you don't have to come back. But I'm going to assume we don't know what the rest of the problem looks like so that I can show you how to come back and fix it to get the rest of the results you need. For now, we're just going to click Compute to get our linear regression line. We see it right here. So we have our slope is 2027. Our intercept is negative, what is that? 3,787,000. So let's come back over. Let's do this so we can still see it, just to make sure we're getting the right numbers. So let's come over here. We know that here, this is our slope is at 2027. Our intercept is negative right there. So that would be the option. Oops, excuse me. I'm so sorry. That is our option down there. That's the slope we need and the intercept we need. Check answer. Fantastic. All right, part B. Normal probability plot of the residuals indicates that the residuals are approximately normally distributed. Test whether a linear relation exists between year and population. Use alpha equals 0.01, level of significance. So first we need to decide what our hypotheses are. Remember, we need this 1. We're looking to see if the slope is not equal to 0. Remember, if that slope is not equal to 0, that tells us that there is a linear relationship. So this is the option we're looking for. Check answer. Fantastic again. Determine the p-value. What's kind of cool here is it already automatically came up when we found our linear regression line. You see here our slope. We come over here, our p-value is it's very close to 0 basically. It says round to 3 decimals. We'll just go ahead and write the 3 out there just to be safe. Check answer. Nice work. All right, state the appropriate conclusion. Choose the correct answer below. Remember, when the p-value is less than alpha, we reject the null hypothesis. So right off the bat, we know we're looking at options A or C. Remember, when we reject the null hypothesis, we say that there is sufficient evidence to support the alternative. So in this case, our alternative is that there is a linear relation between year and population. So looking at option A, we have reject H naught, or the null hypothesis. There is sufficient evidence to conclude that a linear relation exists between year and population. All right, let's check that answer. Good job. All right, draw a scatter diagram treating year as the explanatory variable. Choose the correct graph below. What's kind of cool is that's another thing that was automatically generated. If you click this over arrow, it's one of the automatic selections. We can see here a pretty positive linear correlation in the graph. This option A clearly shows negative correlation. This one shows a curved. Option C is what we're looking at. It's very similar to our plot over here. Final check. Good job. All right, now we need to do the residuals plot. Now, this one does not get automatically generated. So you can click options here, go to edit, and go back to your original options screen and update it. Now, again, once you've done these a few times, you know to go ahead and go down and select these. So we could have selected these from the original screen, but I just wanted to show you guys how you go back and change the options. So I'm going to hit Control or Command, depending if you're using a Mac or a PC, and get that residuals versus X values. Remember, here you have your residuals, and down here you see that the year X is your X axis again. So we're going to go ahead and click Compute again, but I don't see the graph here. That means we need to keep clicking over until we see it. We see a slight U-shaped pattern here, right? Overall, let's take a look and see at our options. This one shows a linear pattern, which is not the case. This one's pretty scattered, so that's not it. This one has that same kind of U-shaped pattern. Let's do final check. Good job. All right. Does a linear model seem appropriate based on the scatter diagram and residual plot? In this case, the answer is no, because when that residual plot shows a pattern, not just a scattered set of data points, when it shows an actual residual pattern, that means the linear model is not appropriate. Let's do our final check. Good job. All right, what is the moral? I'm sure there's a few here, but basically the idea is that even though we looked at the hypothesis test and the linear regression, like the correlation coefficient, all that stuff pointed to a linear regression model. When we look at that residual plot, it tells us this is probably not going to work. So let's go ahead and look. It says like option A says the inferential procedures may indicate a non-linear relationship, but that wasn't what we saw. So we already know that's not what we're looking at. Here we say that the explanatory variables may indicate, that doesn't sound right either, because we're looking explanatory variables, you only have one explanatory variable. Option C says the moral is that the inferential procedures may indicate that a linear relation between the two variables exists, even though diagnostic tools such as residual plots indicate that a linear model is inappropriate, which is exactly what we just found through those steps. So that's clearly the answer we're looking for. Final check. Nice work. All right, and that's it. That's how you do problem number 10. If you have any questions, let me know.